Hello everyone, it's February 17th. Ha! I got another easy one. Not complaining. It just means that we can keep moving on this list. Inverted binary tree. Given a root, invert the tree and return its root. Invert. Huh. So when you swap the tree, I would just swap the child. Swap the children. Yeah, I think you just swap the children. And yeah, you swap the children. That should do, right? Just swap the children. Swap the children. I just did it wrong. I typed it wrong. Swap the children. Swap the children. Do I need to? I mean, I can do root, right? I can do this, right? I do them first, and then I this, and then I'll return root. Oh, I did it before. Was that also a challenge? I don't remember. Six. All right. Maximum subsequence score. You're given two zero-indexed integer arrays of equal length and a positive integer k. You must choose a subsequence of indices from nums1 of length k. For chosen indices, your score is defined as the sum of the selected elements from nums1 multiplied by the minimum of the selected elements from nums2. The minimum of the selected element from, you select things from nums2? Huh. I guess you choose from both nums1 and nums2. It can be defined simply as this blah 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 multiplied by, this is much cleaner. Return the maximum possible score. Interesting problem. So we choose indices 0, 1, 2, and then it will be sum times the four possible subsequence. Well, yeah, it's a 4 choose 3. Yeah, 4 choose 3 is 3. This. No, this is 2. 3, 4. Yeah, 4 possibilities. So that'll be 12. That was only 1, so just 2, 0, 1, 2 times 10. 30 is the maximum possible scores. Now, of course, n is 10 to the 5th. You cannot just, brute force this baby. You gotta be smarter. Be smarter. Alright, so what do you think? What do I think? You need to pick some from nums. Basically, pick some indices, right? And then You say you want a minimum, and you want a sum, and you want a k. And you want the maximum, right? Want the maximum possible scores. So we have this, it's a subsequence. Subsequence k. So we can find a maximum, right? We can find the maximum on the left, sum, but you will have to multiply by the minimum on the right. Yeah, let's try DP. This type of thing usually is DP. Maybe we can figure something out. I mean, do we know the smallest if we pick the subsequent on the second one? Can we know it fast? How do you know it fast? Smallest. Maybe we can sort on nums too. I don't know, just trying. If I sort on nums too. Okay. And we know if we want to pick 3, right? Then the maximum smallest is going to be 2. Right? Because you sorted it, and the maximum smallest is going to be the largest, the smallest of the largest k. So that's going to be the largest, smallest, and then you have to choose these, right? And then we can go into that, go into first, find out what is the sum of this, and after that, you know anything else, it will be a smaller multiplier, right? Yeah, so the maximum small on nums 2 is determined. Right? You know what it is. And of course, if we have repeated values, then those can be okay. And then what? Then I align the first one according to the second one. I don't know, I'm just thinking. No idea. And then if we do it that way, then I immediately know, okay, I can get a sum of this multiplied by this. That's good. But that's the only case. I mean, we can, if it have multiple repeats, we can just not sliding window, because I can pick this, I can pick any of those, right? Yeah, so I want to have on the smallest to be the big one, right? I want the small to be big. If the small is big, and then I want to say under that situation, what is the maximum we can get on the first one? And as this one moves, right? As we move, then we can find the maximum sum on the top. Maximum sum on the top in this range, right? Just anything in this. If we can find the maximum. And how do we do that? We can just, we can go from right to left. Right, we need to find the maximum k minus 1. Right? The maximum k minus 1 from right to left. If we keep track of the maximum k minus 1, how do you keep track of that? How do you keep track of the maximum k minus 1? Well, we can, so the maximum sum, right? So we can sum them up, right? We sum them up. If we sum them up and we move left, right? And we find a new one that's bigger than this. I can pop, I can push. I can maintain a priority queue. We can use priority queue to maintain the largest k. Okay, so we maintain the largest k. And then the bottom just keep moving left, right? If the bottom, the bottom is just because it's the from big to small, and I just keep moving. And every time we move a spot, we have one more available, and we try to find the maximum on the top, right? Because bottom is the maximum, right? Bottom is the maximum. So if bottom is the maximum, and I just need the top to be maximum as well, like the maximum possible. And as that bottom move left, the top will just keep updating, right? Keep updating. Oh, hold on. There's one issue. Because if you choose bottom and then you have to pop the top, right? If we choose this, we can try, right? We say, okay, if we take this, then what will be the top sum? What would be the, so we say if the bottom, the minimum is this value, okay, then what is the maximum we can get from the top? That makes sense to me. That makes a lot of sense to me. Believe it or not, it does make sense to me. We will sort the bottom, right? So we need to import. I need a heap. So we'll sort the bottom, not bottom, sort nums too. But as we sort, we also need to know the indices, so I can rearrange the first one to put them. Oof! How do you rearrange the first one? Damn! I have to create a new one. Don't like it, but that's the way to go. That's the way it is to be. So in a sort, oh god, how do I do this? I will have to say s nums sorted nums2 equals sorted for I, and in enumerate nums2 I'll do ni, right? And I will sort this, and then reordered nums1 equals times line nums1, and then for I for j in range, len nums1, okay? Then we say reordered nums1 hold on. So we'll put, right, we ordered it, so we put this position, we need to go for this. So reorder numbers, I don't really have to pre-fill. I can just say that dot append what? nums1 what? So for I don't need this I in sorted num2, right? And then I just need to do this. We go to look for this one, right? Because yeah, the index has to match. So look for this one, put it in there. So boom, that's that. Which I believe I can do it this way. For this I in sorted num2, nums1 I. Okay, so now we have everything. We need to go for the k, right? And we need to insert the k into a heap. Okay, so heap is gonna be this. Then we're gonna say for this in range k. Nah, How would you want to do this? We can go j. Yeah, we shall go j. J equals len nums1 minus 1, okay? Then we just say for this in range k. So I need to put k into it. We say heap q dot heap push. Heap, we push what in? We push reordered nums1 j, and after push j minus equal 1, right? And then k is smaller than n, so this definitely works. But at the same time, we also need a sum, right? We need a sum, so s plus equal to, oh, don't do it here, do it here, plus equal to reordered nums j. Okay, so now I'm ready, and now we can say res equals to maximum possible, so it'll be 0. Actually, no, this is gonna be s times nums1 minus k 0, right? That's that. Actually, I think we can just do j. Let's see if j is should be j plus 1 or j. So we start from here, right? And then we go 3. So j is this, so j minus 1. J minus 1. And then j minus 1. So j actually will point at the front. So yeah, minus k is safer. Alright, then we should say while j is larger or equal to 0, right? Then for each one, we're gonna try to use this, which means we need to see if it's gonna get bigger. If it's gonna get bigger, then we need to pop the top and push it in. Okay, so we want to see if the sum is gonna get bigger. If the sum is gonna get bigger, hold on. If the sum, right? Wait, we want to keep the sum. We want to keep the sum big, so we shall keep it, right? So we shall take every single thing. We take this and see if it's gonna get bigger. If it does get bigger, we shall do it, right? Because on the nums2 we're getting smaller, right? On nums2 we're getting smaller, so we want the top to get big, to get always the biggest. So we always want a top to get the biggest. So if it can get biggest, I'll take it. And it does not really matter, right? So basically we will say s All right, so we want to take that. I want to compute a new sum. So we can say new s shall equal to s minus heap 0 plus reordered nums1 j. If new s is larger than old s, right? If new s is larger, if it's the same, then it won't change. If it's larger, then we need to try, right? If it's small, then it's not going to be bigger. So if it's larger than, right? If it's larger than, then we can do s is equal to new s, right? If it's larger than, I update and heap q dot heap pop on the pop heap and heap q dot we pop it and the heap q dot heap push, right? I'm gonna push the reordered number j. I'm gonna push it, and then res equals to maximum res, or we have a new s. Yeah, let's do this at the end. Okay, we'll have a new s multiplied by how is this nums1? This is not right. This is sorted nums2 times sorted nums2 j and 0. We just try it, right? And then we update new s. Okay, and then j minus equal 1. So we go to the next one. We try it again. If it's smaller, then we don't consider, because including this is not going to make things any better. So I don't do it, right? And we'll go to the next one. And then up until we finish everything, then we can return res. All right, let's give this a shot. See if this one get it right. I have high confidence because it does make sense to me. Nums1, nums2, max score. Nums1, nums2. Let's see. Too many to unpack. Oh, I forgot. What else? K. Oh, come on, man. Oh, they pass. Now I will test edge cases, because I'm not sure. I haven't tested edge cases yet. So what type of edge cases are there? Well, for example, I have one value. Right, let's say pick 1, because it's the okay. And what we can do is, I don't know, I should just use this, right? One value. How about we use 5? Use all of them. I'll just see if it works. Looks okay. How about now we can do is, wait, hold on. That's good. I don't know, just pretty random, but I want some repeats. Let's try this. We got it. Pretty good, huh? Pretty nice. So sort nums2 and reorder nums1 according to the new indices, and to the reordered indices in nums2. All right. Then we know the maximum mean in nums2 is sorted nums2 minus k. All right. So we also know at this point, the sum of nums1 is the sum of reordered nums1 minus k to the n. This is our starting point. Then we put the k values in nums1 into a heap. We move the pointer from minus k left one at a time. We know that the min in nums2 is going smaller. Thus, the only way to find a larger product is for the sum in nums1 to be big. Thus, we use the heap to keep the largest sum, right, of k values in nums1. Specifically, at each step, we pop the top of the heap and add the new value. If the new sum is larger than the old sum, we keep the larger sum and compute a new possible product. Otherwise, we skip the new value. And do this until we exhaust all numbers and we're done. And it will be O(n) log n. That's for the sort. This is O(n). This is OK. This is O(n).
Oh.
And O(n) log n. So overall, it's just O(n) log n. Not too shabby, isn't it? Huh? I feel pretty alive. Oh my god. Oh, that is smart. Almost exactly the same. Pairs. It's B from big to small. Yep. Oh, yeah, you put this in, you search this. Okay, so, okay, the smaller, not the bigger B is on the front, right? And then you just push this, add this, if this is larger than K, total minus equal to this. Oh yeah, we can keep that every single time. Yeah, that's actually fine. Oh yeah, it's maintained. Because every time you pop, it's gonna be the smallest that gets popped out. Ah. Total plus A. And if it's too much, you pop. And then if it's equal, Then we try current. Oh, fire. This is fire. Ah. That makes sense. So, what would you propose? What I will propose every time, yeah, you add. So for the new one, yeah, I would just say for the new one, you don't add it in first, right? You don't add it in because you want to choose this. You need to know. Yeah, I won't do it that way, but I like the idea of doing this. Zip them. Zip them is actually a good idea. Let's try zip it. Zip it. So again, we need a heap, right? We need a s. We need a res. Okay. Then I can say for AB in sorted zip AB zip nums1 nums2. Why don't you do nums2 nums1, because we're going to sort. All right, and then we say reverse equals true. So actually it's BA, right? And each time we're going to say if, right, len heap is smaller than k, then heap q dot heap push heap and a s plus equal a. I will keep going, right? Else, that means it's equal. Then when we decide whether to put a in, then we will compare, right? We say if now, because it's always going to be bigger, right? We just want to, if we want to take this, so it's the same length, right? But we're missing something here. If it's smaller and then we add it, then it'll become the same. Then we shall do it first. Right, the next time comes in. Yeah, so now we'll push it and go to the next one, come up. It'll be equal to, right? And if it's equal to, I do this first, and then I decide whether to push it in. I don't like how this one's going though. So it's smaller, then we keep adding. If it's smaller, we keep adding, right? And the next one come up. So when it's equal, we didn't really check it. Yeah, I think I have to do it here. If len leap is equal to k. It's the first time, right? So res shall equal to s times b. Then we go, right? It will be equal to them. And then we have to decide. Then we say if a is larger than heap 0. That means swap it out. We'll definitely make it bigger. Then we do heap q dot heap pop. I'm going to s minus equal to heap and heap q dot heap push a. Right? Then s plus equal to a and res equal to maximum res s times b. This is when I use it. And if a is smaller, then we just skip. And then eventually we'll return res. Yeah, this is my version of it. Yep. And this one I do to k times, so I think it's fine. Oopsie doozy. All the test cases are gone. Shoot. Yeah, should be good enough. Yep. It's about the same time. This ain't too special. Okay. Done with this. We'll do it tomorrow. Alright, that'll be it. I'll see you guys tomorrow then. Adios.